before class, yesterday, we discussed the axial circular loop. Magnetic field intensity, I think, is 208. Anil, what's what happened? I think his voice is clear or not? Anyone response? Voice is getting to you? My voice is clear? Anyone response? Just in the chat box. Sir, Madhavan. Very good. Thank you, Madhavan. Okay. Please listen and carefully. Magnetic field intensity H is equal to, you can find it the axis of circular loop. Okay, I am not writing. Okay, I think it's my pen is something went wrong. Okay, I'm stop sharing. I'm again sharing. Wait for 1 minute. Okay, fine. Let me start today's topic about the magnetic field intensity due to someone is just speaking. So what happened? Please listen and carefully and observe the screen. Magnetic field intensity, I am writing MFI. Magnetic field intensity due to the square current carrying wire. In simple way, I'm explanation. There is only one topic today. Magnetic field intensity, square current carrying wire. Before start, we know that magnetic field intensity straight current carrying filament conductor. Then equation, just writing equation, H is equal to, already we discussed, H is equal to I by 4 pi rho cos alpha 2 minus cos alpha 1. Okay, what is this? In the direction of A pi. Already we discussed this topic. Just keep it in mind. We are using this formula in this topic. Magnetic field intensity due to square current carrying conductor. Okay. Consider, first of all I am writing 3-dimensional view. Consider a wire. Okay. First of all, I am writing 3-dimensional view diagram. This is the X, Y. This is Z. Okay. X, Y, Z. Okay. Okay. I am assuming the a wire. Okay. Thus, wire's length is L. This is the wire. Length is the L. Okay. We have in the form of in this bent in the form of the square side, each is the L by 4, each in XY plane shown in the figure. Okay, I'm writing this is the length is L. Okay, total length is L. L is equal to L by 4 plus L by 4 plus L by 4 plus L by 4. Okay, in the form of the square. Okay, I'm assuming in the form of the square. Okay, this is writing. This is a point P. From point P to find out the magnetic field intensity. Okay, it is considered at a point. That point is writing the O or okay point P. Consider we can joining the this is the distance, the middle bend. This is the rho. Okay, in the form of the square. This is the length is in the form of the square. Okay, this is the L by 4. This is the total length L by 4. This is L by 4. This is also L by 4. Okay, consider a length L bent in the form of the square. L by 4, L by 4, L by 4, L by 4. This is also L by 4. This is also L by 4. That is nothing but L, capital L. Okay, that is nothing but 4 L by 4, nothing but this is L. Okay, that's why I write in the just bent in the form. Okay, L by 4, each side is the L by 4. Okay, at a point feet to find out the magnetic field intensity, capital H. Okay, I'm consider this is the, I think this is the A, this is B, this is C, this is the D. Something, okay. I think this origin is, this is the O, so I consider this is the D. Okay, no problem. Let I be current carried by the conductor. This current is I. Okay, this current is also I. Same current flowing in the square form. This is I. Okay, this I. What is this? What is this right hand thumb rule? Okay, in this right hand thumb rule, curve finger nothing but current. This is the magnetic field intensity. Okay, curve finger current, thumb finger is the magnetic field intensity. Okay, consider the side of OA square. Okay, this is the O. Okay, this point. Okay, this is the A. Okay, consider side of OA square and R. Nothing but we distance is rho. I am writing that this is a rho. Okay, fine. This is the rho. Center of the square, which is a difference of rho meters from the side. From the topic about the magnetic field intensity, infinite line current, straight current, carry conductor. We know that this topic is the magnetic field intensity. We can involve. Okay, what is the distance? Okay, in this way we have to connected. This is the angle is. This is the 45 degrees. This is the 45 degrees. What is this? This angle is. This angle is the. What is this? This angle is 135. Okay. To take this is the alpha 1 angle. This is the 135. This is the alpha 2 angle is the 45 degrees. This is alpha 2 45. This is the 45. I think is the, but this is the, okay. This is the L by 4. The half of the term we are using. Okay. Tan 45 that is equal to 1. Okay. Writing L by 4. This is L by 4. This is L by 4. We can angle. This angle is nothing but tan 45 equal to 1. Okay. What I put this is the 45 degrees. Okay. I think tan theta is equal to L by 4 and L by 4 that is equal to 1. And the what is the angle? Tan inverse of 1. What is the angle? Is the 45 degrees. Tan alpha 2 rating. Okay. This is 45 degrees. Nothing but rating is 45. This is the 135. Okay. This is a 135. Okay. We can use this formula, magnetic field intensity. Capital H is equal to I by 4 pi rho cos alpha 2 minus cos alpha 1 in the direction of A pi. Okay. Alpha 2 is equal to what is this? Alpha 2 equal to 45 degrees. Alpha 1 equal to 135. Okay. This is 45. What is this? This is 135. Simple. Okay. Tan, what is the tan 45? Tan 45. Only we can consider this one. What is this? In this one, the tan 45 is nothing but, what is this? This is the distance rho. This is the distance rho. This is nothing but, actually this is the L by 4 in the half of. This is the L by 8. This is the L by 8. Okay. L by 4 we can divide the two sections, L by 8 and L by 8. Okay. What is this? This is the L by 8. Okay, L by 5. Tan 45 is equal to 1. Okay, L by 8. What is the rho? Rho equal to tan 45 equal to 1. Rho equal to L by 8. Just keep it in mind. We are using rho equal to L by 8. Okay, this is nothing but rho equal to L by 8. Okay, H is equal to I divided by 4 pi. What is this? L by 8. What is this? Cos alpha 2. What is the angle? Alpha 2 cos 45. 45 degrees. This alpha 1 is 135 in the direction of A pi. The direction of A pi. Magnetic field intensity H is equal to just write I by 4 pi L cos 45. What is this cos 45? 1 by root 2. Cos 135. That is a minus 1 by root 2. Minus 1 by root 2. This is the A pi. This is A pi. Magnetic field intensity is equal to, just we can derive this, right? What I am writing, this is the HOA only. This is the HOA. Only I consider the HOA in the form of the magnetic field intensity. Just you can derive this 8I by 4 pi L. Okay, some of the people is join the section. 8 by 8I by 4 pi L. Then we can simplification 2 by root 2. Okay, I am writing fast, just only derivation. Okay, that's why I am fast writing. Okay, this is nothing but O to the 8. O to the 8. And the final equation, final conclusion, HYA is equal to 4I by O to the 8. O to the 4. 4I by root 2 pi L the A pi. Again, rewriting, the HOA is equal to 2 root 2 I by pi L, the unit vector of A pi. It's simple. This is the HOA. HOA nothing but due to 1 by 4th of the, this is the 1 by 4th of the square wire. Okay. Due to 1 by 4th of square wire. 1 by 4th of square wire. Okay, what I would find out the total magnetic field intensity nothing but in the bent of the square, total magnetic field intensity, total magnetic field intensity due to square wire, that is equal to H is equal to 4 HOA. Total nothing but in the form of the square. This is the 4. Okay, 1 2 3 4. Just multiplication of 4 into HOA. What is this 4 into HOA? HOA is, we know that the above equation. Okay, this is the HOA. Important, just keep it in your mind. Okay, then the asking the problems also. Okay, you can practice the problems. Okay, just keep it in your mind the last final equation. Okay, it is equal to 4 into what is the HOA? 2 root 2 I by 2 root 2 I by pi L. 2 root 2 I by pi L in the direction of A pi. Okay, the magnetic field intensity H is equal to 4 to the 8. 8 root 2 I by pi L unit vector of A pi. Just keep it in your mind. This is the very important. Okay, just keep it in your mind. This is the magnetic field intensity due to square current carrying wire. Okay, just keep it in mind and asking the problems also. Okay, we're using the problems. This formula very important. Just keep it in mind. I think is understanding. Okay, magnetic field intensity due to square current carrying wire. Chita is also responding. I think 248 is waiting for. Okay, once again, I think this. Once again, I repeat or not. Anyone response? I think I repeated. Just listen. I repeat once again. I think is no need of understanding. Some of the people is speaking. What happened? Are you understanding or not? Who is speaking? Okay, fine. Please, I'm fast. I'm taking the 10 minutes only. Magnetic field intensity due to square current carrying wire. The before section, magnetic field intensity due to straight current carrying filamentary conductor. We can find the infinite conductor. Then after that, the magnetic field intensity due to square current carrying conductor. In this, we are involved the right hand thumb rule. We know that right hand thumb rule. Okay, we can topic about we can involve magnetic field intensity straight current carrying conductor that is equal to I by 4 pi rho cos alpha 2 minus cos alpha 1 A pi. Okay, in the square current carrying wire nothing but taking wire. Okay, taking the wire. Okay, it is bent in the form of the square. Okay, in three-dimensional view. Okay, in the x y or yz, no problem. Any mode. Okay, bent in the form of square. Okay, that is nothing but this is nothing but take total length is L. Okay, total length is L in the square nothing but this is L by 4. 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 Okay, at a point P. Okay, this current nothing but this current flowing in this nothing but in this nothing current flowing in this nothing but okay, nothing but we are using right hand thumb rule. Okay, this current nothing but fingers. Okay, coming in, coming out, or current into the screen, out of the screen, into the screen, out of the screen. The thumb finger nothing but denoted by magnetic field intensity. Okay, we can find out the magnetic field intensity. Nothing but this allocated at the this point, located this point, I taking the red pen, allocated this point. Okay, magnetic field intensity, the magnetic field intensity. Okay, we can connect it this point. This is the distance rho. This is the distance rho. Please listen. This is the distance rho. That's this point. We can divide the length. Total length is this. This length is L by 4. This is L by 8. This is L by 8. Okay, this is the distance rho. Okay, this is the distance rho. We know that what is the rho? Rho is the distance to the connected point O to this A line. Okay, this mid of the A lines. Okay, this is the distance. Okay, we can write the tan theta nothing but tan angle. We can take the alpha to this angle is 45 degrees. We know that by this angle is 45 degrees. That is the L by 4. L by 4 that is equal to the 1. Okay, we take the angle is 45 degrees. This 45, this definitely I writing this 135 degrees. Okay, definitely writing 135. Okay, this is the 135. I think this is the 90 plus 45, that is 135. That's why I'm writing that this is 135 degrees. Nothing but this is the 90. Okay, this 45. Okay, this is the 135 degrees. Okay, just simple. I taking the formula of magnetic field intensity, straight current carrying filamentary conductor. This I taking the topic about the infinite straight current carrying conductor. Just keep it in your mind. The formula we are using the problems also, but I'm not solve the problems. Only derivations. Okay, in this concept, only I'm writing the screen. Just keep it in mind. You can practice the problems. Okay. This is the one of the problem. This is one of the topic about the magnetic field state current carrying filamentary conductor. Okay, this alpha 2 equal 45, alpha 1 equal 135. Tan 45 is nothing but writing this one. This one. This is the 45 degrees. Okay, tan 45. I think it's above this one. Please listen. They are writing this one. This O. This is the point P. This distance rho. This is the 45 degrees. It's nothing but L by 8. Okay, this is tan alpha 2. Tan alpha 2, we can write the, I think the angle is 45 degrees. Alpha 2 is 45 degrees. directly writing the rho equal to L by 8. Okay, just in simplification. HOA equal to I by 4 pi rho, just I can write, I had put in the angles of 45 degrees and 135 degrees. You can get the answer. This is nothing but only HOA, only one side. Due to 1 by 4th of the square, nothing but just multiplication. Okay, due to this 1 by 4th of the square current wire, square current carrying wire. Okay, this is 1 by 4th. The total magnetic field index due to square wire, this one. H into 4 HOA. Just keep it in mind. This equation, competitive is also very important. The PSUs, just given data I and L, just you can find out the magnetic field intensity. Okay. We know that in the above we discussed, but this A pi is also, I can write the A pi that is equal to AL cross, that is the distance, I think not given to the given the problems, arrow. But I will explain the later in the pi, A pi unit vector of A pi. Just keep it in mind, H is equal to I root to I by pi L. Okay, A pi. Okay. I think is tomorrow, I think stop sharing and now section will end. Only one topic, square current carrying wire. Please listen to the in the third unit. Please read the third unit. Okay, magnetic field intensity, Biot-Savart's law, state current carry film conductor, the finite and infinite, semi-infinite, axial circular loop, then square current carrying wire. Just you can practice. Take a pen and paper. You can practice. Okay, you can take a book of the Matthew and Sadiku. Okay, Sadiku, take the book. You can, some of the problems will be there. Just you can put the given, remember the problem, given the formula, just given data, just given the answer, the magnetic field intensity. Okay, I'm stop sharing. I think it's understanding or not. I think just confirmation. After that, stop sharing. I'm given the fast also. Understanding or not? The response in the chat box. If it is not clear, just unmute yourself. Where we not understanding, just response me. Bent in the form of the square. Anyone response? I think is 40 members is presenting participants. There is no need of response in the chat box. Please response. Okay, Aishwarya, thank you. Thank you. Thank you. Only one people has listened the class. Total is absent is 38.